So for section 4.3, we're going to split this up over 2 lessons, but I wanted to start out with a little vocab with you on page 331. Still likely something that you covered in Algebra 2, but let's just talk about the vocab to remind you of these things. So when we look at an angle, so if you started here with this ray and begin rotating counterclockwise, right, and you get that forms this angle that you see right here. You see a little direction arrow. So the ray that we started with is what we call the initial side. The place you end with is called the terminal side, and then that naturally creates the angle in between. As far as standard position goes, we are going to put the initial side on the x-axis, and this will look real familiar to you once we start doing some of these. And then the terminal side, we always rotate counterclockwise from there. So a little vocab if you need to go back to these guys. You got your vertex, which is this guy right here. That makes A the vertex angle. So anyway, a little vocab for you. Let's look at a few things. So for coterminal angles, two angles with the initial side, they got the same initial side and the same terminal side, but they have different measures. So how does that happen? So let's take a look at some of these examples. And we're going to come up with some coterminal angles. So coterminal again means it started in the same position. So in standard position, we start on the x-axis and we rotate counterclockwise. So if I want to rotate about 40 degrees, right, I know it would look something like this. And so I'm rotating right here at 40 degrees. So that's my initial angle. If I want a coterminal angle, that means I need to start here, I need to end here, but it can't be 40 degrees. So how do we do that? Well, quite simple, right? We know that if we go 360 degrees, that's like taking one full lap around. So if I was in this position, if I add 360 to this, it takes me one full lap around, right back to where I started. So if I do an additional, see if I can draw this without screwing up my diagram too much. So I'm going to go from here, and I'm going to rotate 360 degrees like this. So I started at 40 degrees. I'm adding on another 360, so 40 plus 360 we know is 400 degrees. So I'm ending in the same position. I started in the same position, right, with 400 degrees. If I start here and travel 400 degrees, I end up right here where that 40 degree mark was. So these are coterminal angles that have different measures to them, right? So they started in the same place, they ended in the same place, yet they have different measures. So that would be a positive coterminal angle. If I wanted to get a negative coterminal angle, right, we know from this guy, I could travel negative 360 degrees. Puts me right here, but now it's going to be in a negative measure. So if I did 40 degrees minus 360, I'm at negative 320, but I'm in the same ending position. The same terminal side would still be right here, right? So if I started right here at the origin, so I'm at the origin, and I'm going to travel negative 320 degrees. Let me just draw that one. So from here, if I travel negative 320, it puts me right there. So that's from here to here is a negative 320 degrees, but it gives me the same terminal side as this guy had, right? But obviously it's a negative value, so it's a negative coterminal angle. Let's do something in terms of radians. So where would I find 2 pi over 3? As I look at this, remember as you start traveling around your Cartesian plane here, as I start going 90 degrees, we know 90 degrees is the same as pi over 2. Remember, you can always convert by multiplying by pi over 180 if you forget some of these values. So as I go 90 degrees, I'm looking at pi over 2. As I go another 90 degrees, I'm at pi. Another 90 puts me at 3 pi over 2. And then another 90 degrees puts me at 2 pi. Right back to where we started, right? So we always associate the 2 pi with 360 degrees because that's one full lap around. But those are definitely some key values that we want to remember. So where would we find 2 pi over 3? Which quadrant would we be in? So 2 pi over 3, we know would land us somewhere in this neighborhood right here, right, as we move things around. And again, guys, if you ever forget, multiply it by 180 over pi, change it to degrees, and then you'll know where you're at, right? Sometimes it's just easier for us mentally to work with degrees rather than radians. So if you ever need to, just convert it to degrees and then go from there. But if I look at my 2 pi over 3, going to put me somewhere in quadrant 2, right here as I traveled this direction. So I know that angle itself is 2 pi over 3. So if I want to get a coterminal angle with that, I'm going to do the same tricks that I used on this one. If I just add another 360 to that, or we could say if I add 2 pi to that, it's going to give me a coterminal angle. I can also subtract 2 pi to get the negative coterminal angle. So let's take a look at that. So if I have my 2 pi over 3, if I add 2 pi to this, so that would be like adding 6 pi over 3, if you want to think in terms of common denominators. So if I did this plus 6 pi over 3, I'm now going to be looking at 8 pi over 3. And that gives me my positive coterminal angle. If I'm kind of running out of room here, let me do it right here. If I subtract 2 pi, or if you said if I subtract 6 pi over 3, I would get negative 4 pi over 3. All right, so we got my positive coterminal angle. I have a negative coterminal angle. This one, and this one, right? As I draw those angles in a Cartesian plane like this, they would all have a terminal side right here. Right? But it's just different approaches to getting there, right? This one took the shortest route, right? As I looked at 8 pi over 3, so if I travel 8 pi over 3, it's like going like this. It starts here, and it goes all the way around, and it would end right there, 8 pi over 3. If I did negative 4 pi over 3, well, if I start here and travel this direction, right? So the angle of that dotted path, right, would be negative 4 pi over 3 for that angle. All right, let's jump over to this guy. So what if I was at negative 400? So on this one, kind of interesting because negative 400, so if it says negative, I need to travel clockwise. So I'm going to go negative 400 degrees. So if I do this, I'm at negative 360. I need to travel another 40 degrees right there in order to get my negative 400. So here is my terminal side within that one. So this spiral that you see represents a negative 400 degrees. One thing to keep in mind is, what would this reference angle be? Right here, that's something we're going to be working with. So if that's 360 and that's 400, I know my reference angle is 40 degrees right there. So anyway, if I want to get let me start with the easy one. If I want a negative coterminal angle, well, I could go either way on this. I could subtract 360, or I could add 360, and I'm still going to be in the negative. So if I took negative 400 and added 360 to that, right, I'm still in the negative. So negative 40 degrees, which is my reference angle, is a negative coterminal angle. So I could use that one. Guys, there's a bunch. You could use, you could get a whole lot of different answers on this one. So I could continue subtracting 360 from this forever and ever and ever and continue to get more coterminal angles in the negative. From here, what would I do to get a positive coterminal angle? Well, if I added 360, I'm still in the negative, so I have to add another 360 to this in order to get my positive coterminal angle. So if I add 360 onto that guy, 320 degrees will give me a positive coterminal angle. So let's jump on down to this one. So we're going to let theta be. So you guys, you're going to get real used to that theta angle. That's the common variable for an angle. It's a Greek letter, theta. We use that as our variable to represent an angle. So we'll let theta be an acute angle in standard position. Remember, standard position means you started on the x-axis and we traveled counterclockwise in order to create our angle. So it contains the point 5,3. We know that's in quadrant 1, right? Because from 0, 0, if I go over 5 and up 3, I'm in quadrant 1. So we're going to use that to find the remaining trig functions. So real simple, we're going to go back to our basic right triangle on this one. So here's our right triangle. We went right 5 and up 3 in order to get to that point. So how do we find our missing side here? A little Pythagorean theorem. So if we did our 5 squared plus 3 squared equals x squared, let's see, 25 plus 9 gives us 34. So there's our missing side. And then super easy as we go back to these guys, I can now find all of my trig functions that way. So from here, if I did my sine of opposite over hypotenuse, so 3 over rad 34. So if I rationalize the denominator, I want to write this as 3 rad 34 over 34. Will give me my sine function. Remember, to get cosecant, I have to flip sine upside down. I don't really want to do it from here. That's kind of ugly. Be better if you did it from here. So I'm going to do rad 34 over 3 for cosecant. In order to get my cosine, I'm going to do adjacent over hypotenuse. I'm going to run into the same issue that I did here. You might start seeing some shortcuts. 5 over rad 34 becomes 5 rad 34 over 34. And again, for my secant function, I need to flip my cosine upside down. Be easier to do it from here and get rad 34 over 5. Our tangent function, nice and simple. Tangent, we're going to have opposite over adjacent, 3 over 5. Flip that upside down to get cotangent. And we got all 6 functions. One of the things that we're going to learn as we move through is that in order to get our tangent function, we're going to learn that tangent is the same thing as sine over cosine. So if I did my sine value divided by my cosine value, right, you would see it just becomes 3 over 5. So we'll work on more of that as we go through. Let me flip. So we're going to work on just one more example for part 1 here. So this one's nice and short. All right, so using our 6 trig functions determined by a point not in quadrant 1. So now you see on this one, if I travel to negative 2, 5, sorry, up here, that's what they were giving us. So I went negative 2 up 5. That puts me in quadrant 2. Here's where you have to start considering the signs of your answers, right? So as I build this right triangle, I went left 2 and up 5. Remember, you don't have a negative length. The negative describes the direction that you went, right? So I went left 2. That's always going to give me a negative, and then up 5. One thing that we will never get is the hypotenuse will always be a positive, right? This is like the radius of a circle as it travels around. And so this will never be a negative. But your 2 legs can be negative or positive because, again, it just describes the direction that you're traveling. We know right triangles are always formed with the x-axis. So really important as you create these right triangles that we always connect them to the right angle to the x-axis. Never draw it up here connected to the y-axis, right? That's never the way we associate these. We're always looking to form this guy, what we call our reference angle, and the reference angle is always connected to an x-axis, never the y-axis. So let's just fill out some of these guys. So the distance from -2, 5 to the origin is what? What would be this distance, right? So if we use a little Pythagorean theorem, so 4 plus 25 gives me 29. So we know this guy is going to be square root 29. Always positive on the hypotenuse. Let's get this guy. All right, so we're going to fill these out just like we did on the last page. I know sine is opposite over hypotenuse, 5 over rad 29, which we're going to rationalize the denominator and get 5 rad 29 over 29. Again, when you go to do the inverse function, a little ugly to flip it from here. We know if I just do hypotenuse over opposite, I get the cosecant. So rad 29 over 5 for that one. As I get to my cosine, here's where it really matters that you make sure you understood the signs correctly. Adjacent over hypotenuse, I know it's going to be a negative for this one. So -2 over rad 29 is going to become -2 rad 29 over 29. And if we had flipped that upside down originally, I would get rad 29 over 2. Right, and we know it doesn't matter where I put the negative. I could put it with the top, I could put it with the bottom, or I could just put it out front. They're all the same thing. Typically in the answers, I'm sure they'll just put them all out front instead of putting it with the top or the bottom. Tangent, opposite over hypotenuse, or sorry, opposite over adjacent, so -5 over 2. And then the cotangent, if we flip that upside down, 2 over 5. And there's our 6 trig function. So one of the things we want to keep in mind on these guys moving forward is anytime you are in quadrant 2, what do we now know about the signs? I know that in quadrant 2, my sine and cosecant are always going to be positive. Everything else is going to be negative, right? And so we'll talk more about those signs as we move forward. But yeah, all goes back to these basic right triangles that we're drawing within the quadrants.